Hello there, and welcome to this next episode of State Machine Corner. I'm Dr. Bruce Powell Douglas, and I'll be your guide. Today I want to talk about using state machines to collaborate. So as you build parts in SysML or objects in UML based on classes in UML and blocks in SysML, each of those can be defined by a state machine that defines its behavior. And so far we've only considered how they work in isolation, not how they collaborate together. So in this installment, I want to talk about how we can connect different elements in different ways and allow them to collaborate using state machines. Before we get started, these state machines that we're going to be using will include events or signals, as they're called in Cameo, with values that they pass around. And I want to quickly show you how to do that. So here we have Rhapsody shown here. You can easily add a state machine, add new state chart. We can add a state. The easy way to add an event is to just add a transition and type in the event. Here we have two states, and we can now add a transition between them, and we'll add an event, EV1. And when I do that, we go to the package here, we see that there's an event, EV1, that's added. What if I want to pass a value with that event? How do I specify that? It's pretty simple, but you do have to bring up the specification of that event in Rhapsody. So go to the event, and you can type it, or double click on it. You can select arguments, and you can now specify arguments. So let's pass three arguments. Let's say A and B, which are type real, and a string. So we can add a argument. We'll have A, and we want that to be real. We'll use Rhapsody real here. There are other options, but that works fine. B, also of type Rhapsody real. The default type in Rhapsody is integer. So here's a Rhapsody real. And then C, which is going to be a string. And we just use Rhapsody string for that. And here is Rhapsody string. So now we've added an event with these three values, and you can see with the parameters in the browser. Cameo is just as easy to do. If we bring up the Cameo tool, here I've got my test block as we had before. I will add a new diagram, so create diagram state machine. Here's my state, and I'll just do a transition off to another state. Go. And if I type an event here, EV1, we see in the browser there's a new event right there, EV1. I want to add parameters to it, slightly different terminology than in Rhapsody. Here I add what are called attributes to it. So bring up the specification dialog for the event EV1, and there are attributes on the left-hand side of the specification dialog, and I can create them in exactly the same way. So let's add a new attribute. We'll call it A, and it's going to be of type. We'll just use SysML types. In this case, real. We'll let the type checking engine find the real type. Click on close. We'll add another one. We'll call this B. Also of type real. Click on the type. I'll do autocomplete. And then we will add our third C of type string, and we'll use a SysML type string. str, and let it do complete, and there's my string type. So now we've defined this event, EV1, with these three attributes. Later on, when we send that signal, so just to be clear, Cameo calls them signals rather than events. It's Rhapsody vocabularies, they're called events. When I'm going to send that, I need to send particular values, and they are part of the parameter list or the event reception. Over the definition of the signal, they're called attributes. With that, let's get started. What we see here is a simple MVC model view controller system. It's got a model, which is our data source. It could be a sensor, some other source of information. That's the model over here. The controller, which is meant to manipulate the data and manage the information, doing whatever it needs to do. And then the view, which is then used to display. We're going to connect up these systems in a couple of different ways to show you how you can collaborate with state machines. Now, UML and SysML have two different ways of creating collaborations. One way is with an association, as shown here. An association builds collaboration based on type, because controller, model, and view here are types. So I can connect from controller to a view, or any subtype of that, because it's a type of thing I can connect to. So that's a reasonable thing to do. The other way I can build collaborations up is with interface compliance. And that's where we use ports. These are proxy ports in SysML, shown here and here. These are typed by an interface block, I model controller. The naming convention I use is I, or interface block, followed by the name of the unconjugated side, underscore, name of the conjugated side. So here we see that this is the unconjugated side of the model end, and the conjugated side at the other end, of the controller end. The naming of the ports is a standard thing that I do, pretty common, P followed by the name of the thing I'm going to connect to. So controller has a port called P model, and model has a port called P controller. These two elements are going to be collaborating over these ports, which are then typed by this interface block. Now, if you look at the model view controller context here, that contains these parts via these composition relationships. We can look at that IBD. We go into our browser. We see there's an internal block diagram. We can open that up, and we can see how they connect. This connection is done with a connector directly between these two parts. Now, Rhapsody, when I draw this connector, looks at the model and says, oh, there is an association between those. That's probably the type that you wanted to use for that. That's relevant because Cameo doesn't do that. Okay? Cameo, you have to explicitly type it yourself. And then I have a connector between these two ports. I can do that because they're of the same type, but one's conjugated from the other. So that is the structure of this model. So now we can look at some of the information in the model. So let's look first of all at the model state machine. We can just double click on the diagram here, and we see that it basically is a very simple state machine. We're waiting for a request. The controller will send it an EV request data, and then it does a send back. Here's the datum. I'm using the random function of C++ to provide a random value, and I specify the port that I'm going to send it to. That's done in the specification dialog for that, where I can specify how I want to connect it. That's the target. The only target here is the port, so that's fine. That's the target. And I can specify what event I want, and I can select the event. And if the event has a value, as it does in this case, in the dialog, I can just add the value. So really pretty simple state machine. If I look at the controller state machine, it's a little more complicated. Now the controller state machine has an initializing state where it's basically sending out a request and it's updating the value. If we look back at our BDD, we see that the controller block has an array of real values called incoming, and there's 4 of them. The work it's going to do is a moving average of the last 4 values. So what it has to do is go get some values, perform the average, and send the average over to the display. So here we do the initialization, we get the first 4 values. Let's go ahead and zoom in a little bit. We request the data, we send that out this port again. We can specify that bring up the specification dialog. Here now, we see there are 2 different ways I can specify the target. I've got my P model port, but I also have that association. But in this case, I want to send it out to the model, and that's over the port. And then I'm sending out the EV request data. There's no data associated with that request, just give me some data. So there's nothing else to fill in there. When we get the event back, here's the datum, we dereference that value. So Rhapsody creates a struct called params with all the parameters passed from that along with that event. And we can then dereference that, pointer to that struct. So we get the value that way, and we stick it in incoming 0. We do it again, incoming 1, incoming 2, incoming 3. We set an index value, which is going to be used later when we do our moving average. We create an average of the 4 values, so we sum them up, divided by 4, and then we tell the view to print this out. Now the view, we're going to call a synchronous function defined on view, called print. Print takes a string, so we're going to dereference our reference pointer to that, the roll end, the reference property. Dereference that to invoke the synchronous operation print, and we're going to pass it a string to go do that. Then we're going to basically operate it. So every 2 seconds, we're going to send out a request for more information. So we're going to, first thing we do when you come in the operating state, print out the value. Now here we're going to call it asynchronously. So we call it asynchronously. We're going to send the target out is identified by the reference property, here the roll end name, right? That's done here. And then we're going to send EV print. That's going to take, it has a parameter called S, which is the type real, and we pass it the place where we put the computed value called datum. And that's where we're going to pass off to the asynchronous call to print the value in the view part. Then we go to a waiting state. We wait 2 seconds, which is 2,000 milliseconds, and then we send the request back out to the model, and then we do some math. We print out the concurrent value, so we get the data, update the index. That's where, remember I said we're going to use index. Update the parameters valued by new reference, do the math to get the moving average, and then we update our index modulo 4, so we wrap around and fill in the latest 4 values. So after we request the data, we're going to tell it off to print, and we go back waiting for the next bit of data. So we wait for the data, we do this, and then we wait for some more data. So once we get, here's the data, that's what passes the information, we update our moving average, get it, and then we can do that until we decide to stop by sending an EV stop event. Now let's look at the view state machine. So here's a view object. We see it both has an event reception for EV print, which receives a real. It also has a print, which takes a string and prints print. So we have synchronous call and asynchronous. So in the state machine, very simple state machine, it means you get the EV print, and again we get params out to pull out the parameter, and we're just sending it standard output, standard C++ output. Pretty straightforward. Let's go ahead and run this. So I already built a component to run it in, and we can just go ahead and run this. And we're running with an animated state machine. So let's go ahead and kick it off. And we see it does some stuff. I can make this a little bit bigger. We see that it sent the request. We got here the data back with some values. Send it out again to get the first 4 values. And we have the print state. We're in this terminal state. And we're waiting for that state machine to receive the next event. We can also look at the animated state machine. So if we go off to the controller, we can go to the instance and open up the animated state machine. Instance state chart. And we see that's where we are in the current state. Zoom to fit there. Now I can say go, and we can watch it run. So I will now insert an event. I can just right-click here. I can insert an event, generate events. And I want to generate the EVGo event, this one there. And we see it sends the event out. And over in the corner, we see it's printing out results as it performs this moving average work. Pretty straightforward. We can look at the activity sequence diagram being drawn, and we see it dynamically create this view as we execute. And now we go back to our state machine. Where's our state machine? There's our state machine. We can insert that event now, the EV stop. So we can generate events. In this case, we want to do EV stop, die, and we generate, and it stops. So far, so good. So let's review the ways in which we interacted. We go back to our BDD. We see that there were 2 ways that we connected up these blocks, not including the context. One way was with the connector between these ports on the IBD, and the other way on the IBD was to connect an instance of the association by type. We simply send events. In Rhapsody, you can specify whether it's over a port or whether it's over a connector typed by an association, and the receiving state machine can process it. I showed you how you can call synchronously as well. It's pretty easy to do, or asynchronously by sending the event over this connector. Very straightforward. All right, now let's do exactly the same thing in Cameo. We see essentially the same model in Cameo. We've got our context, our model, our controller, our view. We've got an association, directed association between the controller and view. We've got ports typed by this interface block, named in exactly the same way. Although in Cameo, we don't actually have to use the interface block. We also in Rhapsody have to explicitly say that these ports are behavioral. By default, they're delegation ports, that is behavioral except to false. If you wanted to execute that behavior, you have to click on that box on the features dialog to make it behavioral port. Cameo was forgiving there. We also don't need to define the ports with the controller, but we can certainly add it. We'll add it there, and we'll make this one conjugated. So life is good. All right, so we've got this connected up here. We can look at our IBD. Here's my IBD connected with the controller here, and this view here. Now notice the comment here. With Cameo, let me just delete that. Yeah. So yes, delete that. So we have no connection. Let's go ahead and add that connector. So add a connector. So here's my connector. Add it. And let's look at that connector and see what its type is. When we look at type, we see there is no type. So this actually will not work in execution until it's typed. Which association did you mean? Now, if you look at it, there's only one association there. Cameo could have said, oh, you must mean that, like Rhapsody does. It doesn't. Just be aware. Okay, so that's that. Let's now go look back at our state machine. So let's look at, remember we started the model before in Rhapsody. Let's look at the model state machine. So here we're waiting for request, and we've got request, and we've got this action. Before, remember, we had a send action on the state machine. Now we don't have that. Why? Cameo doesn't let you put a send action on a state machine. That's just, well, annoying. That's the way Cameo works, but fine. Instead, what we have to do is we have to create an activity diagram where that's defined. The send action is defined in an activity diagram. So if we go there, we can just do an Alt B to get to that block in the containment tree. You can open up that activity diagram, and it's a very simple. We see that it receives the value, and it just creates an output. Now remember, the language I'm using here, Cameo doesn't support C++ out of the box, so I'm using Groovy, which is based on Java. So I'm getting output value from random. I'm sending it out to this pin. As before, remember I just had a dialog, I just type in the value. And out here via P controller. If I look in the send action here, there's an on port property. The on port property allows me to select which port I want to send it out. And so if it's connected with ports, it's pretty easy and straightforward to say, send this signal out to that port. But now I need two diagrams. Rhapsody I needed one, Cameo I need two. Let's go back to our BDD. Let's look at the controller. The controller state machine looks very similar to what we had before. There's initializing, and then there's operating. But remember what the Rhapsody model looked like, right? In the Rhapsody model, we had, go back over to here, we just had sends, the send actions, and directly connected. Can't do that in Cameo, so we have to have states where we've got this send request. Now it's not complicated, but it does require a separate diagram. So if we go to this, Alt B again, go to that behavior, which was request data activity. Oh, come on. Here we go. It's really simple activity diagram, but it is a separate diagram. So you do have to bring that up. So we have these states where we wait for this response. Here's the data, and we have this incoming value set to value. Now, the incoming value set to value is within what's called an opaque expression. Here's my opaque expression here. And in the behavioral element, we have specified explicitly that there's a parameter, input value. If you don't specify that there's a parameter, even though you've defined these attributes of the signal, you can't use that in the ensuing response, effect, or input or output entry or action. You have to explicitly say that. Now, Cameo could say, oh, you've got this event has these attributes. Since you're using the event, you probably want access to those values via parameters and create the parameters. It doesn't. It's an extra step you have to go through, just saying. So as long as you do that, that's fine. And here we do the same thing. We set incoming of 0 to value. We go get those four values. What's this? These four values, incoming of 0, 1, 2, and 3. Cool. And then we set index to 0. We set datum to the average of those values. Then we send, we call the synchronous value on print done. Let's go back and look at view. It has an operation called print. Let's look at that. Oops. Go back to here. Specification. Here's specification. We've got an operation here called print. Here's my print. And it's in Rhapsody, if I want to implement a print operation, it's pretty straightforward. There's just a tab. I type in the print operation. Let me just show you in Rhapsody what that looks like. In Rhapsody, I go to the view. Here's print. Specification dialog. Here's my arguments where I specify the incoming argument. And here's my implementation. Right. Just put it in field in the specification. It's not what you do in Cameo. In Cameo, what you're going to do is you have to create a separate method, which in this case is an opaque behavior. And the opaque behavior has to have parameters that can accept it because it's being called. So you have to open the opaque behavior of this. If you go to opaque behavior for this is print, so it's under view. Here's my opaque behavior print. Here's my operation, and here is my print string, opaque behavior, print string. And I have to explicitly add the parameters to match up the method with the operation. Again, an extra step I have to go through. And given that, then I can add the behavior itself to it. And here we see that behavior itself is defined inside here is just as printf. And again, I'm using the Groovy language because Groovy has a print statement. Okay, so in the state machine then, for control, I've actually got this print done activity, which is going to invoke that synchronous call. Let's see how that happens. So the name of the activity diagram is print done act. So if you look at, this is in controller, go back up to controller, and there's print done act. That's this guy. Okay. Okay, now before, I just simply send a string as part of the value I'm sending over. But here I have to have a read value specification, and this explicitly must be typed as a literal string. I have to select value specification as a literal string, okay? And then I give it a value here, and the value I give it here was we are done, enter ev go. Now I want to invoke print. Print is defined by this block called view. But there may be multiple view instances out there. Which one am I talking to? Well, it's the one to which I have a reference property. So I have to have a reference property. Here's called cView. Remember, if you go back to my IBD, that was cView here, right? I named it explicitly so you see it's different from other references. The activity diagram. Okay, so that becomes the target. So before, when I wanted to invoke a service, I could do it over a port, and there's an on port. Here, because I'm using a reference property, I have to talk about the reference property as a target. So this, if I look at the, this is again controller. There is a reference property here called cView. And that is that reference property you reference. So I can get one of those by dragging and dropping it here. Right. But now, which reference property or which instance of the block? Well, that's where read self is necessary. So I have to read self to give me the pointer to the current instance of controller, then read its reference property cView, and pass that reference property off as the target for the print statement. And then I pass the value of the print operation to invoke it. So a few more steps involved than in Rhapsody. Going back to the state machine. So then we're done again. We're waiting for the EV go. So let's zoom in a little bit here. Now we go into the same thing. We have a requesting state. It's a little bit differently organized in Rhapsody. Remember Rhapsody? Let's bring up Rhapsody again. In Rhapsody, we had this. We send out to the asynchronous invocation of the EV print to print the value, wait, send the event, process it, go back in. Cameo is a little bit differently because of how Cameo works. So we go directly to requesting. In requesting, we have an entry action, send value to display activity. And I use the ACT and the activity just to help remind me what kind of behavior I've got associated there. So if we go to controller and look at send print, you can look at that diagram. Same thing. We have to, but in this case, we still have to send called EV_print by specifying the target, because remember, it's an instance of an association for typing that connector. Still have to use the same reference property here, so it needs to have read self. But we also want to pass a local value. So we have a value property named datum. And I want to pass the value held in datum, because remember we had that math, we sum up the 4 and divide it by 4 to get the average, put it in datum. To get datum, we have so datum from which object, what instance of controller? Well, the current instance, so I need to read self. So I could have just done this twice, but I had a fork to put the object reference in both of those, read those two things, put it in the send action to send it off to print. Again, something I didn't need to do in Rhapsody. I can just use that feature dialog, just specify that, and boom, there it goes. Back to PDD. And then we can look at the view state machine itself. Pretty simple. In this case, we've got EV_print, and we've got an action print output. So that is just an opaque action. Now, if I actually type this in and hit enter, most of the time, Cameo will just break in terms of the parser, and it'll actually name the transition this and not correctly identify this is an event and this is an action. So you should enter the event, then in the specification dialog, enter the action. If we look at that action, that's under effect. So here we see it's an opaque behavior, and this behavioral element, and here's the string, print output. And again, we have to specify the parameter explicitly. Cameo won't do it for us. Specify that there's a parameter being passed in so that I can reference that parameter here. Okay, so let's run this now. So I did create a separate view, and this is a pretty nice feature in Cameo. I can, in Rhapsody, I can put multiple diagrams side by side or switch between them. In Cameo, I can just put multiple views of diagrams on another diagram and watch it execute, which is actually a nice feature. I do like that. So let's go ahead and run that, and we will also create an animated sequence diagram. So here I'm ready to run. I'm waiting for that. We can expose values here. We see you haven't assigned any values yet. Okay, fine. We can do our step. Let's go ahead and watch this execute. And we see it in fact runs through this. Bang, 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 bang. And it says, we're done. Enter EVGo. So it works the same. We see our states here and the activity diagrams execute here. If we look in the values area, we can see the values of the different parts of the array. Remember, there are 4 elements in the array. We can see the current datum, which is the averaged value. We can see the value of indexed. So let's go ahead and do go. So when we did this, we specified 2-second delay. And we're going to do the request data activity. Again, that's a simple send that one signal, send action, or send signal action. And then we go to waiting. When we get here's the data back, then we're going to get the value and process the value, update index modulo, solve modular arithmetic. Now, interesting problem I came across was index is defined as an int. We go to controller. Here's controller. We can look at the value properties, and we see, in fact, there's a value property called index, which is of type integer. An index type integer. However, used as an index, simulation engine treats it like a real. Took me a little bit of time to figure out. I need to create a local stand-in variable, int, which is a groovy way of specifying an integer, and use that. So I assign it the value and then use that as the index. It took a little bit of time and some help from my wife to find that, but we got that working, and so now we can send EVGo. So let's insert that event. I select controller, insert that event EVGo, and we can now watch it execute. In the console, we see the output values as it's processing the value here, right? It's running, producing outputs. Let's also now rerun this, or rerun it from scratch. So I'm going to close this out, because I want to create that animated sequence diagram. And we also can watch this execute in the simulation view I created here. So we will now get this ready to run. I will select context, and I will create a sequence diagram. And let's run this. So we see the collaboration starts up, it starts exchanging messages, and at some point it gets down to we're ready to rock and roll, we're done, enter EVGO. Now I can enter the EVGO. And we see it's now beginning to process this. Now, interestingly enough, we'll let this run a little bit. We see some values being output. We see the collaboration going on. And we're calling both synchronous and asynchronous behaviors being invoked. Let's go ahead and go to the controller, and we will then enter in the controller. Let's go ahead and just pause this. Pause. No, really. Pause. There we go. An interesting thing to note is that we have two lifelines corresponding to view here. One which is started up, and then the one we're dereferencing. These are actually the same thing. There's only one instance. If we look at the owner here, there is only one instance of view. Only one of those is existing in the simulation, and yet we show it as two lifelines, which I find odd. But anyway, you can see how the collaboration constructs up the animated sequence diagram. It shows up these state invariants just like Rhapsody did. So it works pretty much the same. So here's an example of how you can use state machines in parts in SysML models or UML models in either Rhapsody or Cameo, and invoke synchronous and asynchronous surfaces with ports and without ports. I hope you found this interesting. If you like the video, please click like. If you have comments, please add comments. If you want to subscribe or to be notified when new episodes of this comes out or other videos on my channel, please feel free to do so. With that, have a great day.